Alright, today's lesson was on proving segment relationships. We just wanted to prove some relationships about line segments. To start off, we needed to know a handful of basic, commonly used definitions and relationships, postulates, and theorems about those relationships. Take a minute to pause and write down these definitions. Alright, I do want you to know that this IFF here, and IFF here are not typos. I want you to remember that IFF means if and only if. Indicating that we got a biconditional statement there, another biconditional statement here, another biconditional statement there. These reasons, these ideas, these relationships, they are all things you already sort of know. Segment addition postulate is just saying AB plus BC is the same as AC. You can do that as long as you see that B is between A and C. But also, if you see that AB plus BC equals AC, you can say that B is between them. Congruence. If things are congruent, then they're equal. If things are equal, then they're congruent. You'll see this used a couple times. You know that we can add, subtract, multiply, and divide both sides of an equation, and it'll keep things equal. So we might not say algebraic property, we might say adding property of equality, subtraction property of equality, multiplication property of equality, or division property of equality. What we do to both sides will keep things equal. Then we had definition of midpoint, making sure that all 3 points we're talking about are collinear. We get to say B is the midpoint of a line segment AC if this statement is true, if AB is equal to BC, if the length of AB is equal to the length of BC. We also get to go the other way. If AB and C are collinear, if we see AB is equal to BC, then we know B is the midpoint of AC. These statements get to go back and forth. We also have a midpoint theorem, which is if M is the midpoint of AB, then AM, the line segment AM, is congruent to the line segment MB. Notice this is going in one direction. It's not a biconditional statement like if. Only if things are M is the midpoint, then we can say things are congruent. But just because two things are congruent doesn't mean that M is necessarily the midpoint. We get to go in one way, but not in the other. We had another proof today we were going to go over. We went over in class. As a reminder, we had this sort of pattern for our proofs. We would have statements and reasons in our proofs. We'd always start with something that was given to us, and we'd always be trying to prove and end with what we wanted here. Remember that statements are specific. Statements are specific to the problem, while reasons are general ideas. Most classes today, we took a minute to identify if the items in our word bank were either specific statements or general reasons. A definition, particularly definition of congruence, is a general idea. That was a reason for us. QT equals RV, that's rather specific. It's specific to this problem. It's a statement. Given appears all the time. It's a reason. QR plus RT equals RT plus TV. That's really specific. That's not talking about any points. It's talking about very specifically those points. It's a statement. The rest of our ideas were reasons. Subtraction, segment addition, and substitution are all reasons that we might use in a proof. Now that we've at least identified our reasons and our statements, we can sort of go through the two-column proof. It's going to be easier for us to do so. We can approach it with a test-taking strategy, but we can also approach it with the regular class logical approach. We're starting with a given statement that line segment QT is congruent to line segment RV. We're saying this entire length from Q to T is the same as this entire length from R to V. We're saying those are congruent. We get to go an extra step from that then, and we get to use our definition of congruence here. Well, let's take a look. Our definition of congruent says if things are congruent, then they are equal. These were congruent, so we get to say they're equal. We get to use our first statement here. QT will equal RV. Whenever you use a statement, you should absolutely cross it off, because you'll be given your choices in a word bank. It's a good choice to cross them off. At least the statements for sure. You could end up using the reasons more than once, though. Now we've got QR plus RT equals QT, and RT plus TV equals RV. We got two separate statements there. Let's focus on them one at a time. QT is the same as QR plus RT. Q to T does look exactly the same as QR and RV. We've got a segment here from Q to R. We've got a segment from R to T. Together they do make QT. Segments are being combined. They're being put together. We've got something similar. R to V is R to T, and T to V put together. They're added together. Since I see segments are being added to make a longer segment, we get to say it's segment addition. We've used our reason. I'm not going to cross it off because we might use it again. You never really restate statements, but you might reuse reasons. Next, for number 4, we need to figure out what the next line would be. We had QT equals RV. QT here is equivalent to QR and RT. So what we can do is say this QT up here gets to be replaced by QR and RT. QT is being replaced by QR and RT. QR plus RT. We can tell it's going to be this next statement up here just by that fact. We know RV is the same as RT plus TV, so we get to say we are equal to RT plus TV. We took one statement We traded out the left-hand side for something else. We traded out the right-hand side for something else. When we're swapping statements here, when we're trading out one part of an equation for another part of an equation, that's commonly substitution. That'd be our substitution property. You could just as easily write substitution. You don't necessarily need to write property of equality. You might occasionally see other names than substitution, but right now this is pretty much the best case to see substitution here. Here we see it happening twice, though. Technically, we have it happening once on the right and once on the left. From line 4 to line 5, we see that the only change is now we're subtracting RT on the left-hand side and on the right-hand side. And that lines up with our subtraction property. We're subtracting something on both sides, so things remain equal. That's one of our algebraic properties. Adding or subtracting, multiplying or dividing, both sides keeps things equal. We get to keep things equal here. Now, if we think what happens when we subtract RT from both sides, we'll notice RT minus RT is just nothing. It's 0. It goes away. RT minus RT goes away. We're left with TV. We can see we're left with QR equals TV. The line from 5 to 6, the reason behind it, could be a handful of things. We could say we are using substitution again. We could also say we are simplifying. Last, we went from QR equals TV, the length of QR equals the length of TV, to line segment QR is congruent to line segment TV. We did that using our definition of congruence. We've finally proven what we wanted to prove here. There were 3 other terms we took a look at. We wrote them down below here. We had some congruence properties. AB is congruent to AB is our reflexive property. If AB is congruent to CD, then CD is congruent to AB is our symmetric property. We get to just swap the 2 sides on either side of the congruent sign. And we had a transitive property. If AB is congruent to CD and CD is congruent to EF, then AB is congruent to EF. Those are the reflexive, symmetric, and transitive properties. In this case of congruent, because they're all using congruence signs. If you wanted the reflexive property of equality, it's going to look exactly the same, except using equal signs instead. We had this page of notes that we completed in class. Along with this page of notes, you received on the back of it this page here, which had a 2-column proof, which I asked you guys to spend some time working on. We did a little bit of it together in class, but I asked you guys to finish it up. And we also did some test review in most classes. My next video will go over this answer and the test review.